Hello to all. I'm glad to be able to present to you now my topic. It's about the top-down engineering according to IEC 61850 with DIGSI. I will first have a short presentation, but as you know, this is a training, as my colleague the last session was also doing. So I of course have with me DIGSI on my computer, and I will show you with a real example how this method works. But let me start with a short introduction with the explanation of the basic idea. What is a SSD file, how to make best use of it. These are general tips and hints independent from our implementation. The next short introduction part is about DIGSI, how DIGSI 5 supports this top-down engineering. I will shortly explain you on the slides the new import specification editor and explain you how DIGSI supports to fit these cProtect devices to the requirements coming from the SSD file. And then we can come with this knowledge. You are able to follow hopefully my use cases, the training example, and I will close with a short summary. Top-down engineering, 61850 introduction. The basic idea. The engineering is also described in the 61850. This is the part -6. So 61850 is really capable of the whole workflow. It's not just describing communication or modeling of functionality, it's also about the engineering. And this is our topic in this session. The system specification tool is able to describe such a substation description, so it's not just one protection device, it's the whole substation containing of several bay devices, including their topology, their communication, and so on. So I have here mentioned the 4 parts of such an SSD file: substation structure, device part, data types, network. Such a tool is independent, vendor independent. So the sense of this is that you do not fix a vendor like Siemens. You just describe your requirements, quite neutral. This file, what is the outcome of such a tool, replaces other analog descriptions. For example, Excel files, Excel lists with signals, drawings with topology, or Word, even Word files which describe which protection functionality you need. All this can be part of this SSD file in a standardized way. As I said, it is vendor independent, it's a functional description, and of course, since it's a file in a standardized language, it's machine readable, and this is what we make use of with DIGSI. Examples of such tools are, for example, the well-known Heylings tool from H&S, there exists such a tool, or Calcitech, but there are many more. These are just some examples. Let's have a closer look to the possibilities and the parts of which such an SSD file can consist. The substation structure you can imagine as the topology. I have here such a small single line diagram. You see here 3 bays. This is also my example later, so we will look into details here later. Then there is a part with the data types. This is a little more theoretical. There you can describe how the protection functionality shall look like. The device part is a list of expected IEDs, what you want to have in your substation. And the network part simply describes the communication, how many subnets, the IP addresses, if you want to have goose communication, relationships, such things are contained there. These 4 parts are optional, so you can use all 4 of them, but you don't have to. It makes sense if you want to use the workflow I am talking about, of course, to specify the devices, the IED. Otherwise, DIGSI has difficulties in looking which devices shall be created. So very helpful for us is substation structure, devices. That I would say is the minimum to start. But all 4 parts are welcome. So now how to make best use of it. It is a very powerful tool what you can have here with such a system configuration tool. So there are some rules which is good when you follow them. One tip is to use typicals in this substation, in the system configuration tool. The ideal version for the engineer who later on has the wish to use Siemens CPROTEC 5 devices is to use typicals coming out of the DIGSI, so that we have already a description which can then be quickly fit to with our DIGSI 5. These typicals here in this case would have the standard CPROTEC 5 naming. In my example later I will have one of the base be based on such a Siemens ICD from CPROTEC 5. But of course I will also have the other case that the device is based on something coming out of the library of the system configuration tool without knowing how the implementation in CPROTEC 5 is. This SSD file is then imported to DIGSI 5. This is the new functionality we have implemented last year. And then you can have here the substation instance create the substation instance from that project. You can have the normal exchange of the SCD file with the syscon, and you then have the configured IED descriptions, the CID files, which can then be downloaded to the devices. DIGSI has now the capability to do some automatic actions here. It can create the device instances automatically. You don't need to drag and drop them from the DIGSI library in the hardware editor. DIGSI in such a constellation can also use these ICD files here and can automatically multiply the device instances. We will see it in the example for 2 devices to show the principle. Then DIGSI can rename the devices from the typical naming to the name they shall have in the substation instance, what we are describing here. And of course also the IP addresses can be used. So we are sort of extending DIGSI here to the substation view, to the device overlooking view. DIGSI can do more than just opening one device, then configuring the setting of one protection device and then opening the next one. It's a substation view here. We can set the IP addresses, we do the namings and so on. So to enter this, we have a new entry in the project navigation tree. It can be found under the IEC 61850 station entry, and it's called Import Specification Editor. When you click on this, you get a view something like this. Here I've already selected a file so that you can see something. The principle is the following. On the left side we show the input. It's a sort of requirements list. The input from this SSD or SCD file. The extension doesn't play a role. Both file types are described in the so-called SCL substation configuration language, which is based on XML, extendable markup language. You don't need to remain that, it's not so important, but for those who know this, it may be interesting. You can also view these files with an XML editor. I will also show later in my example. DIGSI makes it clearly visible, so this is the advantage of this editor. DIGSI filters the view so that you can easily see what is described here. On the right side, DIGSI, the new editor, shows the content of the devices in the DIGSI project. Here in this case, nothing has been selected, so it's not much coverage here. It's no coverage because no devices have been selected. It's just to show the principle. We will go and fill out this right part here in the example later in this session. So the workflow is to have on the right side the requirement, on the left side the devices, and the task of the engineer, where DIGSI supports here, is to choose the right devices, to create instances as much as they are needed here and to configure the right logical nodes, logical devices, and data objects. Yeah, so the first step, let's go through the steps you need here. The first step is to create a protection device in DIGSI 5 to cover the IED and map it. There are several ways. Either you start from the scratch, you don't have the typicals available, then you have to have a certain knowledge about the required protection functions. On the left side, you then choose on your own the device. If you have the typical where the device instance from the SSD is based on, then your work is much simpler. You can of course just open this DEX file, import the DEX file to DIGSI and use it, and then you have a higher coverage. If you have mapped it, then you can compare. You drill down, you open the objects and compare the device with the IED section input from your SSD file. For example, you want to create a logical node. You just select them from the column mapping recommendation. You get some recommendations, what the device is offering, and you can then select in the row before, in the column before, what you want to have and create it by clicking on that blue create icon or button. Then this logical node is created in the CProtect 5 device. It then appears in this column here. In this case, it's a PTOC, what is required on the left side. You remember this was the input from our SSD file, so the meaning of a requirements list. Then you can drill down. It can be the case that there are missing data objects in the LN. You can prepare the LN type for all of these other missing objects. For example, user-defined objects, which are then created as a GGIO. If you select the hierarchical overlapping blue icon, then all of these objects are created which are below this logical node. DIGSI reports then what has been done. In this case, we have created a lot of devices, a lot of logical devices and data objects. Some are missing. All of this is recorded here in the logs, and you can easily see what has happened. So the majority has been created. Some data objects have been requested which are optional from the standardization, which are not available, so DIGSI cannot create them. This is also reported here. So this is what I meant. It is a powerful tool you can require for devices which are not available. So it's a good idea to use the ICDs from real device in this SCT tool. Another important capability of DIGSI, what we implemented, is to create multiple device instances from a typical device. This is another workflow. Here you see that 3 Feldleitgeräte, in German, bay control devices, are requested on the left side of the editor. And I know now that these base on the same device, typical. So I can use this attach DEX file functionality here, map 3 times the same device here. So I click on the appearance of these 3 instances where I know they base on the same DEX file. I browse here 1 time to the DEX file where it is, and then it is attached here for all 3 instances. If I then create on the import, then these 3 devices are created in the real DIGSI project. So now they are available for the mapping. And they have, what I mentioned before in the introduction, they have the naming, what is requested, and also the IP addresses from the SSD file. So this is a very elegant way You can imagine it works not only for 3 instances, but also for 10 or for 20. And this saves a lot of work where you otherwise would need to copy the device or create it one by one from the library. And then open each device, change the naming, enter the IP address, and so on. So let's come to the theoretical use cases if the templates do not fit well. This case I've already discussed. This is the simplest one. The template fits well. DIGSI has to create the instances, rename, and use IP addresses. No structural changes. This is quite a simple one. You should notify that we have now implemented this import of a new device, of a new file type SSD. The second case is that someone in the SCT tool did a change here. He added, so he used templates from CProtect 5 devices, but he has the wish that in the substation instance some details change. So let's assume he has created additional user-defined logical nodes. In this case, DIGSI supports in creating this user-defined logical nodes. What do we understand with user-defined LNs? These typically are the G and the S nodes. So the GGIO as a general logical node for results from CFC. The sensor nodes, for example, sensor for insulation monitoring, gas, and so on. Typically, the functionality behind that is created with CFC. So DIGSI supports there. And we also have implemented the extension by functional LNs. Functional LNs typically are the protection LNs. Functional means the function behind these logical nodes is a software in the devices. PTOC is the protection time over current, PDIS is the protection distance, and so on. So these can also be offered in the new editor as a mapping recommendation, and you just click on it and then it is created in the real device and you get it instantly listed with all the 61850 details and can look further for eventual differences which can also then be filled. Let's now come to our training example. My example consists of 3 simple bays, 2 feeders and 1 coupler bay. I have assumed that the 2 feeder bays will be covered with protection, with a time over current protection functionality. For the coupler, I have assigned a bay control device. To give you a small flavor, this is how such an SSD file looks. If you look into it with an XML editor, for example with a Notepad editor, you can see it looks machine readable, it looks like something for experts, but don't worry, you can see some of the parts which I mentioned here. You see the substation, the topology level with a voltage level 110 kV. I think it's quite well readable for us protection guys. You see here that the topology is organized in 5 topological elements, 2 bus bars and the 3 bays. And you can also see here the 3 IEDs already. And if you look here a little bit deeper, then you can even see here that one of them, this is the one based on the ICD from the DIGSI, which I exported to the tool. The other one based on the library. You can also see here and also in the top line that I've used here the Helix tool as an example. I don't want to give you a training in the Helix tool, but it's of course helpful to create such simple examples, and of course we must understand what's going on there. So here, this I've already mentioned, this is the new specification editor. Our task will be to import the specification and to create these 3 devices, and then we'll make some adaptations to show you how DIGSI supports these use cases. So let's switch to DIGSI and explore the possibilities. Before we can even have a short look into this SCT tool. You see here there's a part for the topology. Here's a part describing the communication part where I can assign the IP addresses. Here's a part where I can add the functionalities to the bay. This is the view of the bay D01. Here you can see I've added the ptalk. On the right side you can see there is a library with all kind of logical nodes defined in a standard. I've chosen here edition 2, and this is the dangerous thing here. So here you can add a lot of functionality. Here everything is listed what is described in the standard. So be careful if you select here a device to think about it, whether this is existing or not, because DIGSI can configure, but of course not create new functionality. Okay, that shall be enough. Here, this is what I've shown. This is the XML file where you can, of course, drill down a little more. But let's do DIGSI the work and interpret what is requested here in the device. If I would look here into the device, it's quite a lot of lines in here. You see here, even this small example has nearly 8,000 lines of code. So let's do DIGSI, do the work, and import this file. What I will do is start from the scratch. I will create an empty project where I import the SSD file, use my typicals, and create the devices. So let's look for the new editor. It's here, import specification. Here you select the file. I have here this simple SSD. And you see here, DIGSI shows it much more convenient. We can have a look in the topology here first. So we see here the voltage level, the 5 topological elements. In the base, we see the current transformer, the voltage transformer. For switching devices, the overcurrent protection functionality, where also the device is described. However, it's much more comfortable. Here the device is also described under each of the topological elements. Of course, for someone like us who has the task to now engineer the devices, the view of the IEDs here, it's much more comfortable. So here we have the 3 IEDs as a requirements list in this 61850 language. You see here already the difference between the D1 and the D02 base. In the D01, let's have a look. This is the device from the library, from the SCT tool. Here you see it looks different than the view here. This device bases on the Siemens ICD, and it uses our library and our description. So let's now have the devices created. I use here the attach DEX file button. You see here the 3 devices are offered. I know that I want to use the 7SJ for both of the feeders. I have one DEX file for them, and I want to use, they are assigned automatically to both of them because I have selected them here. And for the bay controller, the coupler, I have prepared the 6MD85 device. And if I now click on import, these 3 devices are created by DIGSI. It will take 2 minutes or so, and then we can see the difference in the mapping results in this editor if we map the devices to these 2 different IEC 61850 descriptions here. What DIGSI does now helps us a lot, because otherwise I would need to instantiate 3 devices from the library, would need to rename them, would need to assign the IP addresses to them, and then maybe have a look, switch from one device to another. It's something very useful, which I can only recommend to you for use. Yeah, the next step is then here, okay, I got also a log here, 3 devices successfully created. They will be listed here in my project view. And now I can see DIGSI already selected here the mappings for them, because it is clear what I want to have. I've assigned them already. Yeah, and here now the next columns come into play. You see here a rough estimation, a rough overview how well these fit, and you see here a difference that here 28 logical devices match and no one does not match, whereas you remember this was the device based on the ICD, whereas here there is a lot of blank pages where no match is found. Yeah, we can have now a small exercise to look into the details and to close the gaps here. I will close this here to have a better overview. So here you see one little logical node is missing here. Let's drill down what is missing here. You see here the mapping of the PTRC did not fit. So I do this manually here. I know that it is this one here, and then I have a 100% LD match. So not much work with the device, which you remember based on the ICD from the DIGSI. We have now here the full match. Here we would have a little more effort to work with. DIGSI tries to map, but it's not so successful here. I must assist a little bit. LD0 is the application, the LPHD I can map. So all this is in the list, and you see here how then the green process is shown. However, I have to look into it here. Line was modeled. There is no line in the device. Here, the overcurrent, I would have to use the overcurrent functionality. The circuit breaker should match for this one here. So I must unmap it first here to be able to map it. Then here, the circuit breaker CB1. And then I can go down, map the circuit breaker consists of the CLO from the circuit breaker, the CSWI from the circuit breaker, the XCBR from the circuit breaker. And you see here how DIGSI shows the progress, what we do in creating the device. So the meaning of this editor and the support for you is that DIGSI shows the input from the required substation and shows you the progress, what the device is, what you're configuring is currently having. And the best thing is everything what you do in this editor is really then in the device what you have here in the tree. So you are working really in the device. When you are finished, you save your work and you can download the configuration directly from the DIGSI. You've seen that it's much less work if the requested device is basing on a device which has been described from the DIGSI as a typical. There are some rules in working with typicals also. I can recommend to have less number but large functionality in the typicals and then not use everything here and so on. Yeah, that was the presentation part. I would then come back shortly to my summary in the PowerPoint. Here we are. So, top-down engineering according to 61850-8 offers the digitalization of the substation automation and protection engineering. It is faster. Remember the creation of the devices. It is automatic instead of manual data exchange, so you avoid errors. A typical based approach is most effective, and I can recommend only to use a library of existing devices based on ICD files in the system configuration tool. Thank you very much for watching. This is, I've shown a release DIGSI, so it is contained in the DIGSI available everywhere. This was the version 9.0. We will extend the functionality a little bit also including the import of protection settings coming from the SSD file. Thank you very much for watching. And now I'm open for the questions.
Thank you, Markus, for presenting. That was an interesting journey through the presentation and through the tool itself. And it was interesting for the auditorium. As I can see, we have a lot of questions out there. Thanks for placing them here. I think some of them had been placed rather early in the presentation, so it could be that you already answered them in the presentation, but nevertheless, we want to emphasize on answering those too. So does DIGSI support any third-party vendor IED library? For example, can I download ICD file of the third-party vendor to the DIGSI?
No, DIGSI cannot use it. That makes no sense. Our syscon can use third-party ICDs to connect them to our system. The use case to use ICDs from a third-party vendor is that the customer wants to connect them. He has the devices together with the Siemens devices, and we can connect them, for example, with Goose communication. And this is done not in the DIGSI, it's done in the syscon. We cannot turn a device from the red or blue vendor into a Siemens device by magic. That's not possible.
Good to know that, kind of. And is there a firmware requirement for the import specification tool?
It can be used from the DIGSI from last summer. It's 8.80, but this is of course backwards compatible also for older CProtect versions. So no, there is no requirement for a certain device firmware.
Okay.
It's just a DIGSI feature. It has nothing to do with the device firmware.
Okay, thank you. How can we create the SCD or SSD file? Is there a Siemens software tool for it? If I remember correctly, it's external tools, right?
Yeah, no. Yeah, we've thought about this, but we decided not to create a Siemens tool because, as I mentioned, the sense is to have a vendor-independent tool here. And I think it doesn't make sense to buy this. I would not buy such a tool in a vendor because I would think he built something in that only his devices are supported or have a benefit for it. It is contradictory to the meaning of the attempt of the standardization. And there are enough tools. We have even some cases that customers are building their own tools. They want to be completely independent.
Fully understood. Thanks. And I think we have somebody who watched the presentation before, because now the question is, the structure built in the Simaris, can it be imported in the DIGSI 5?
Yeah, that's a good question. The topology, I must admit, I don't know the formats which the Simaris tool uses for the topology. And I don't think that there is much information about the protection functionality. It is a planning tool for dimensioning of the primary system. So what we could use, I think, is the topology. So the task would be to export and import the topology. I would need to exchange with my colleague about possible formats there. And I think the ideal way would be from Simaris into the SCT tool and then into the SCL format. Because this is in between, I think. If you have the planning result, then you would design, the next step would be to design the protection functionality. So the input should go, from my understanding, to this substation configuration tool. But I will discuss a little bit with my colleague.
Perfect. We have the question, so we will deliver an answer, and this could be via mail. And now the next question is, can DIGSI develop any system architecture documentation, for example, network topology, through indication Ethernet switch, RTU, or gateway?
Oh, I'm not sure what you mean with architecture description here. I think it's the documentation issue. The communication part is then outsourced in the Syscon, in our Syscon tool. So it would be, this has the complete overview of this engineering. We could do so, but we would need to discuss how, for example, the information about the gateway is coming from. This is currently not handled in DIGSI. This is more a substation-wide system. We have other tools for that, and yeah, it's also something. Thank you for the idea. We can discuss which is the best place for that with my colleagues.
Perfect. Thank you. And this brings me to the other possibility. I think I need to place this question here into the room. Until when is the exhibition with our experts in it open? Is it still open tomorrow with experts talk, or that's just today? Okay, so we'll take this question and the experts will discuss. I think you will receive an answer. So can DIGSI perform validation of the SCD file in accordance with IEC 61850? Yes, it will. If it finds something, you for sure will get in the logbox a message if something is wrong. Okay. And then does Siemens plan to implement the capacity to create SSDs with generic IEDs on DIGSI 5? Oh, I'm not sure what a generic IED is. We can, of course, export the result of our configuration. This is then typically called SCD. It is the result. Then the IED names are written in Siemens 7SJ85, for example. The configuration is done. The file type is then SCD, and of course, this can be exported. And it can also be imported again in the SCT tool. That's no problem. This is probably related to a question that sounds similar to me, because why this presentation related to the DIGSI's capability refers to the Healings STC IEC integration tool. It seems to me DIGSI is not capable to create SSD file. Yeah, that I tried to explain. This is just an example. We are not related to Healings. We can also use other tools. That's the first point. And the idea from the standardization is to create a vendor-independent description with this XML file. So the idea from the standardization, which has been created together with you, the users, is there has to be a vendor-independent description. And we can take it and realize the requirements described in this file with our Siemens cProtect devices. That's the idea. It's nothing that we miss it out, that we cannot do it and we need an external tool because we cannot do it. It's the idea to have the external tool, and the customer then can send this also using requesting offers. It's not just can be used for now please configure the devices. It can also be used, please give me an offer for this protection functionality. No? Okay, so just an add-on, not that we require it, but more than the market requires it, right? Okay, thanks. And then it's a question, I think it's from the device, more from the cProtect view. Why can't we download the configuration from the device, edit it as required, and then upload it back to the device? Why is the limit to the original project file only? This functionality we have added last year in DIGSI. This is something, it has nothing to do, from my understanding, with the topic I presented today, but I know this was a long requested functionality, and this is possible with the version I think we released last summer. We can do it. It's a project merge. Look into the DIGSI manual and look for project merge, and then you will find it. Oh, perfect. So it was a great question, and we all have the specialist here to answer it. And the same probably applies to all the procedures we saw. Are they available also in previous versions of DIGSI 5? We started to implement this in the summer version last year. 860 had the non-functional, the user-defined
logical nodes are supported there. Then in the autumn version we added the PTOCs, the functional LNs, and now we have the full-blown version in the 9.0. So you can go back 2 versions and you will have you will find this editor, but we added continuously functionality until the now actual version 9.0. So you can open your DIGSI, look in the 61850 folder. If you have this import specification editor, you can start with the functionality.
Okay. And one question is, can I download the software DIGSI for free?
Yes, you can. You can work without the license for 31 days. 1 month is free, and then you have to buy a license.
Oh, okay. And let me check for one last question. We take the time for one last question. It is, okay, can Syscon be used as an SCT? It means to subscribe GOOS messages on other IED's vendors? Oh, hopefully you understand that. I don't.
Syscon is not an SCT. It misses some basic functionality. It does not have a library where you can drag and drop the functionality. Syscon is designed for configuring the communication part of a substation. It has no library where you can drag and drop PTOCs or topology or some things like this. It's a pure communication editor. So no, it can read the SCD or the SSD file. It can add communication, but it cannot create a requirements list from the functional side of the devices.
Okay, thanks a lot. So thank you for all those questions. The one not already answered will be answered afterwards via mail. And if questions come to your mind later, feel free to contact us. We will get back to you. And as I already mentioned, yes, we recorded this session, and the recording will be automatically available to all participants directly after the session. And this includes access to all previous sessions too. So I hope you had the chance to join a lot of interesting presentations and to meet our experts. The exhibition area will, I think, stay open for a day for downloads. No. Yep. Oh, not only tomorrow, but mid of April. So the exhibition area will stay there. So thanks again for joining us for this year's World of Electrification and Automation. I'm looking forward to meeting you during one of our next events, be it virtual or in presence. Markus, thanks for your time for presenting here. Dear auditorium, thank you for staying the whole 2 days with us. Stay safe and sound. Take care. And goodbye for this year's World of Electrification and Automation.
Thank you very much. Goodbye.